Hey everyone, this is Vikram. Welcome back to my channel Learn and Reflect. Today we are continuing our in-depth series on sorting algorithms, all based on our comprehensive GitHub README file, which I have linked in the description below. After bubble sort, our next fundamental algorithm is selection sort. So let's scroll down. So what is the concept for selection sort? It finds the minimum element and places it at the beginning of the array. So this is a minimum selection strategy algorithm. Let's take a look at the code snippet. Now in case of selection sort, we have two for loops, the outer for loop and the inner for loop. The outer for loop starts with I equal to 0 to n minus 1. Now I is the position where we will place the next minimum element. Now before placing, let's just assume that the first unsorted element is the minimum. So min index is I. Now the inner loop goes from I plus 1 up until the length of the array. Its job is to find the actual minimum in the remaining unsorted portion. And if we find a smaller element, we will update our minimum index. Alright. Now once we are done with this inner loop, we have found the minimum index. Now we will do a swap only if we have found a smaller element which is different than what we have assumed in the beginning. So this optimization reduces unnecessary swaps when element is already in the correct position. Now again, let's take a look through a step-by-step walkthrough example. In this case, I have an initial array which is 64, 25, 12, 22 and 11. Now in the pass one, remember what does selection sort do? It will find the minimum from this array, in this case it is 11, and it will try to place it at the beginning of the array. That means it will have to do a swap for 64 and 11. So now 11 is in the sorted position. In the second pass, from the remaining unsorted array, we find the minimum, which is 12 in this case, and we will do a swap of 25 and 12. So now we have 11 and 12 sorted. So we'll keep on repeating this until the array is sorted as 11, 12, 22, 25, 64. Okay, so that's about the selection sorting algorithm. Now what is the complexity for this? In all cases, it is O of n square. Why? Because we have these two for loops, the outer loop and the inner loop. The space complexity is O of 1 because it is a in-place sorting algorithm. Stability, no, it is not. Why? Because it can change the relative order of the equal elements. Now, when to use this algorithm? We use this when minimizing the number of swaps is important, which is exactly n minus 1. This is what the selection sort is doing. Okay, so we have the optimization, but otherwise selection sort does n minus 1 swaps. We use this algorithm when memory writes are expensive and when a simple implementation is needed. Okay. Now, as we discussed in the bubble sort, in our README file towards the end, we also have a complete algorithm comparison table. So here you can take a look at selection sort, compare its best case, average case, worst case time complexity, the stability, space requirements, and when to use it against the other algorithms that we are discussing in this series. All right. So make sure you are subscribed to Learn and Reflect so you don't miss our deep dives into the rest of the algorithms. We will explore when to use each one, the interview insights, and even more. So thanks for watching, and I'll see you in the next video.